Good afternoon, everybody. I appreciate the time of being here today. As mentioned, my topic is a little bit different than what we've been talking about today. I was invited to speak here as part of an article that was published in the PEI Journal back in April. And it is directly in regards to the off-road mandate exposes the need for cleaner diesel. As we all know, on the off-road side of the equation, Tier 4 and the initiatives and the compliance is something that's slated to take place for 2018. In the on-road environment, it's been there since 2011 to 2014 area. So we're going through a lot of the learning curve, which fortunately we had some of the same manufacturers that are here that have been through that before. But one of the things, just a little bit background, I actually work for two different companies. Hydac Corporation, which we do basically systems and components for every application. A few people here ask me who we are and what we do. We have a global footprint throughout the world. But Hydac owns Schroeder Industries. Hydac is based out of Salzburg, Germany. We have a global footprint. We are primarily on the largest publicly owned hydraulics company in the world, and we've taken some of the technology that we've developed over there and are utilizing that in our fuel side of the equation, fuel filtration primarily. We are both in the bulk side of the equation and for the on-engine and for the pre-filtration side of the equation. But there's really three things that are happening. When I was asked what's taken place in the industry, I've been involved in the industry for 25 years. Back when I first got involved in the business, fuel filter was basically a rock catcher. As long as you had a rock catcher that was there at 100 microns with a built-in screen, you were good to go. The engines could eat up water, they could eat up rocks, boulders, and anything that you put into them. Tier 2, Tier 3, a little bit more sensitive, but oh boy, Tier 4, whole new ball game that's out there. I ask people, I deal with both the design side of the equation. I'm responsible for design. I'm responsible for the marketing side, responsible for developing solutions that are based in the market. And I primarily start a lot of times or hear from the end user, the fleet owner, and how that rolls up into the customer itself. And one of the things that is for the end user that are out there and the fleet owners is a misconception about Tier 4 and the technology that's out there. They believe the engines aren't as reliable. There's a perception out there that they're a lot more sensitive. Some people could argue that perception is absolutely true. However, with all the new technology, with all the costs that are being associated with it, there's very, very little that's being done both on the educational process for the bulk side and for the forward development process going forward for the on-engine products. i.e. being said, what worked 25 years ago does not work effectively the same as what it does today. Talk to a fleet user, end user, are you having any fuel quality problems? Oh, none whatsoever. You peel back the onion a little bit more. Well, how's your HPRC systems running? Are your high pressure injection rail systems running? Oh my God, we've got problems with those left and right. What about your after treatment systems? Oh, we've got problems with those that are related from the crashing and the burning of the injector systems that are in there that are putting too much fuel into the after treatment systems. And oh, by the way, our fuel filters, we have a huge biological problem that's out there. Okay, no fuel quality problems, but those are all the same things that directly lead to a quality problem. When we look at this and you look at, I'm sorry, I'm still getting used to the slide here. When you look back at this slide here, going back one slide, common rail system, the big thing that I want to take away, and it was just brought up in the last presentation, is the amount of pressure going through the orifice. When you look at the common rail systems that are out there today, Tier 4, they're operating on an average of about 30,000 PSI, some of them in the system today at about 50,000 PSI, down to 2 microns in orifice. They're moving to 70,000 PSI injection pressures with a half a micron orifice. Very, very sensitive to water, both in the dissolved and the emulsified side of the equation. Free a whole nother game to that. But they're also very, very sensitive to finer particulate product that's out there today. And the fact of that is when you are looking at a high pressure common rail system, 4 to 6 liter system is a $5,000 pressure, or excuse me, a $5,000 system or more to repair. A lot of the engine sizes that we're talking about here today are considerably higher than that. There's a trifecta in the industry that I think is kind of going on based on some of the data that we've had and trying to understand what the issues are along with trying to educate our customers and our OEMs that are out there. But you've got the Tier 4 regulations, you've got the Tier 4 high pressure common rail systems. That's number one game changer that's in the industry. Number two, though, is the introduction of USLD 15, ultra low sulfur diesel 15. The last few years, there's been a change over to that. Off-road diesel is still at a different level than the on-road diesel. But your ultra-low sulfur diesels have a tendency of holding and absorbing more water than what the old high sulfur diesels did. That creates a larger problem when you start to get into the cold start issues that are out there and the lubricity guides. Part of what also happens is when you're removing the sulfur from the fuel itself, you are removing part of the lubricity agents that naturally occur within the fuel itself. They put additives back into that package to be able to blend them, mainly for the wear materials that are in there. But part of the thing that happens is surfactants are introduced into the systems, and it lowers the surface tension of the fuel. When you lower the surface tension of the fuel itself, that directly relates how effective the filters are at being able to do it. If the fuel is too thin, it's very difficult to remove the water. If the fuel is too thick, it's also very difficult to remove the water. Most of all the testing that's been done in the background has been between about 20 and 30 dynes. You're finding now that the biofuels and ultra-low sulfur diesel in its raw state without even a biodiesel blend are operating somewhere down between the 8 to 10 dynes area. That is a big, big problem in removing the water. The third thing that's happening in the industry today is the addition of on top of the ultra-low sulfur diesel is the addition of biodiesel. Biodiesel blends are not mandated regularly across the country. Most engine designers and fleet users are anywhere from a B2 to a B20. Most of them somewhere in the B5 to the B15 range. But what a lot of people really don't understand is the amount of water that biodiesel can hold in a saturated form. When you're looking at when you are looking at a B2 blend, you're somewhere around 250 parts per million of water, B5, 500 parts per million, and up to 1,600 parts per million for B2, it basically at ambient temperature outside during the summertime. When you look at the surface tension, I'm going to show you a couple different slides here, but when you look at this slide right here, this is basically showing you a colleague of mine I used to work with at my previous company, Dr. Christina Sannefeld, was one of the first ones that really kind of came to me and said, part of the technology that we really need to work on is the new medias that we're working on and to be able to separate the lower surface tensions of fluids that were out there. My previous employer didn't really pay too much attention to that. They said, hey, what's been working for us has worked great throughout the years. We're going to continue to go with what we have until there's a real need to be able to change this. Well, what we found in the lab is over the course of time that the products that were effectively working throughout this prior to that were no longer working effectively when you put USLD along with the biodiesel blends in there. And part of the issue that you look at is when you look at the saturation curves, the dissolved water versus the free water. This is a B5 blend, and if you're looking basically in an ambient temperature here, outdoor during the summertime, say 300 ppm of water. What happens in certain environments at night? At night, temperature drops, goes down to 60 degrees. Now all of a sudden, that solution is 150, 175 ppm of water. Where'd the water go? The water's still there, isn't it? What it did is it went from a dissolved state into a free state. That free water at night fell to the bottom of the tank that's in there. Following morning, you go to start up that equipment. Where does the tank pump pull from? The bottom of the tank. You've got emulsified water that's being fed into the system. When you look at a B10 blend, that almost doubles in size as compared to a B15 blend that's on there. So when you put the three of these together and you're talking about taking out the particulates and you're talking about taking out the water, along with the addition of biodiesel and ultra-sulfur, it's a game changer that's out there that's taking place today. What our company is trying to do is to protect your investments from the OEM, protect the fleet users that are out there so they have a product that works more effectively, works to its design parameters and standards for what you designed to. When I first made my bones in the industry, I worked with the automotive companies, Ford, GMs, and Chrysler, in the fuel side of the equation. When you're designing a fuel system and or an interval change out for your fuel filter, say 500 hours, you have a set point. You have X amount of fuel that's going through the system. You have an X amount that needs to be delivered at a certain cleanliness level. So as an engineer, we all have to start off with where we ended up, but we have to start off with a known, correct? Where that known starts off, as long as it remains consistent, all of our systems and all of our equipment operates effectively. What happens is when that starting point changes. When that starting point changes, guess what? All bets are off after that. So to kind of look back at this, the big factor I'm going to really kind of zero in on is the water side of the equation. Water was not a big, huge deal in the diesel side of the equation 10 years ago. Today, it's a much, much larger issue than what it was. You keep the boulders out, you're all right. But water today and the lower lubricity that you've got with USLD is a big game changer that's out there. Bacteria. Anybody here ever see bacteria in the fuel tanks of either the equipment or out in the field? There's another major game changer that's out here is most of your fleet users, most of your end customers have not upgraded their infrastructure. They're using the same infrastructure that they've had for years and years and years. Same day tanks that are out there, the same fuel tanks that have got sludge and sediment at the bottom of those that have not been cleaned for years upon years and years. Bacteria is a huge, huge problem that's out there in the system, both for the after treatment systems, for the injection systems, and then also for the fuel filters themselves. When you look at, going back to the question I originally posed, customer end user, do you have any fuel quality problems? No, none whatsoever. Well, you start to go down. Well, are you having any high pressure, are you having any high pressure common rail problems? Are you having pump failures? Yes, matter of fact, our new Tier 4 equipment that we've got in, I've got more pump failures and injector failures on the Tier 4 equipment than I have on my old 2 Tiers and 3s combined all together. I've also got shortened life of my fuel filters that are supposed to be on the engine and on the pre-rail itself. My intervals and service intervals are not being met to where they need to be, and I also see both free water and emulsified water in my system. Well, sir, in the big picture, respectively, doesn't that mean you probably have something going on in your system? And realistically, that all revolves around fuel quality issues, which directly are related to operational expenses, high maintenance cost, unexpected downtime, schedule delays, reliability expectations aren't being met, along with increased fuel cost. What does all that lead to? It leads to bad customer satisfaction. So I like Jamie's analogy that he used earlier. You know, he's got a product, but nobody wants to buy it, kind of like the Motorola phone. Well, I've got a product that everybody needs, but nobody wants to spend the money for it at certain times, both on the bulk and on the mobile side of the equation. When you're looking at the impacts, what directly are the impacts? When you have bad fuel, I'm still getting used to this. When you have bad fuel in a system, this is a high pressure common rail system. The injector poppet here, it may be a little difficult to see from out in the audience, but there is some pitting in that that's on the tip of that injector seat from emulsified water that's in the system. The scoring that you see on the injector seat here is obviously from particulate components. Over a period of time, this starts to wear, and you put more fuel into the after treatment system than what it was originally designed to do. Then you look down at the lubricity side for the wear plate that you've got for the high pressure pump that's in there. All that will not only take up the injection system, but that can also start to overwhelm your after treatment systems that you have in too, which are the things that we're trying to protect. Uptime. Water within the system itself, you look at this is basically your diesel, your water, and the microbial growth that grows. The more you turn the fluid, the better off you're going to be, but once you have microbial growth or fungus within a system in itself, it's almost next to impossible to thoroughly get out with doing a complete cleansing of both the day tank, the fuel tank, and the system itself. And this will give you an idea of what the filter of that would look like right there. Microbial growth, existing filtration, if you're currently using what has been, or the end users are using what they've been using for the last 25 years, I can just about assure you that the old cellulose technology that's out there is not cutting the muster for what they need. You look at the lower IFTs, you look at the high pressure common rail pressures that need to be, along with the existing bulk tanks with the free H2O microbial growth that's out there. Those are all big game changers. So much so that in 2012, and remember Tier 11, or 2011 was when Tier 4 interim had occurred for over-the-road vehicles. 2014 is when it was compliant. But in 2012, all of your major manufacturers for both engines and for the injectors, Bosch, Denso, Delphi, all those guys got together with a common position statement because there were so many injector failures. There were so many after-treatment failures that are out there. What do we do? Well, they had to go back to what they were doing in the lab. Instead of reinventing the wheel, they adopted the ISO code, the International Standards Organization for Cleanliness Specs. And what they basically arrived at was a worldwide fuel charter saying that in all of your bulk tanks that are out there, you need to be at an 18, 16, 13. So that when we deliver to our fuel tank, we can then take our fuel tank, dispense that down to a 15, 13, 10, and between our pre-filter and our engine filters, we can get to an 11.83 at the injector. For us that have been in the industry, that is a big game changer that's there. To give you another visual, this is typically what we see in a patch test in a common bulk tank that's out there, 22, 21, 19. 30 micron cellulose spin-on filters have been pretty much the standard norm for dispensing filters for a long period of time. But as you guys know that have been in the industry, when we're talking about an ISO standard that's 4, 6, and 14 micron in size, we're not even touching those parameters there. Especially when you look at a 12, 11, 6, which is where you need to operate at the injector side, you need to go from here to here. How much in the real world do you think people are paying attention to that statement right there? Probably not a lot. In the hydraulics sector, where I first grew up at, it was a big educational process. It's still an educational process to this day in the hydraulics. Pressure filters, air filters, return line filters. When you look at the care and the work that went into protecting those systems, we wonder at times now, why hasn't that same work and added gone into the on-engine products that are there? In some areas, it has. Some manufacturers are doing a great job. Other areas, it hasn't been as effective. But all manufacturers, regardless of where it's at, your equipment is out of your control once it goes into a user's hand. And the user can put anything into that fuel tank that he wants to, and they commonly do. And then they have problems that affect it down the road. When you look at that same spectrum, oops, I gave you just a minute ago, this is basically what your bulk fuel looks like. This is what the ISO mandate is saying that you need to be, along with all your other major OEMs that are out there, in the fuel tank. But you need to be at a 15, 13, 10, so our on-frame and on-engine filters can get us down to the 11.86. How do you do that? It doesn't just magically happen. How you end up doing that is you have to have a very comprehensive strategy on how you're going to effectively handle your fuel. From both the bulk side to the equation into the main tank, from filtering, these are both particulate filters, and then liquid water separators that are on there. Water separators are a huge, huge factor. For those of us that are in the south or in the humid environments, you get during the summertime, what happens to your fuel tank? Whether it be your day tank that's out here and or your tank here. You're in a hot, humid environment. I'm right outside the Memphis area. It's 85 degrees humidity for 6 months plus out of the year that's there. As that tank is breathing in and out, you're pulling that humidity into the tank. So you have to have some way to mitigate that. And that's really what we're talking about. Regardless of how bad the fuel is if you properly mitigate it at each one of its junctions coming in, by the time it gets to the fuel vehicle itself, it can be able to provide and operate effectively in where you need it to be. I was asked also as part of this, what does good look like, what does bad look like? I only had 30 minutes to basically give you about an hour and a half worth of material in a very, very short period of time. So this was about the best I could come up with. This is what bad looks like. This particular customer right here is a railway customer, and it is a mobile refueling truck that is out there that's basically bringing fuel to all the equipment that is servicing the railways. They're starting to get in a flood of the new Tier 4 engines that are coming on board, and they had a massive, massive amount of failures with their Tier 4 engines for all the very same reasons I gave you earlier, shortened filter life. They had Tier 4 injector failures, high-pressure pump failures, and they were having after-treatment system failures. They asked us to take a comprehensive look and approach it, both the bulk side and the on-engine side to the equation, which we did. And the example was what they were trying to do is get down to a 15, 13, 10 with a spin-on filter that didn't look like it had been changed in probably 30 years. And what happens in fuel filtration? Fuel filtration has bypass built into it. So as long as you have flow going through the filter and fuel comes out, we're in great shape, right? But that all goes into the systems. And those are the things that we're trying to protect. So what we did is we worked with this customer here to have a particulate filter followed by a coalescer. Coalescers remove the water. Particulate filters are important because it's a very important strategy that we use within HYDAC. A lot of people will try and have one filter bolt in for both particulate and coalescing, and that's going to solve all your problems. The problem that you have is coalescing doesn't effectively happen very well when you have a lot of particulates on the filter. So the art of filtering that is to basically have a particulate filter to remove all the particulates so that the coalescers can do their job, and that's being able to remove the water in a dynamic fashion over a period of time. Theoretically, the coalescers can last well over a year or indefinitely, providing you keep the particulate off of it. But the comprehensive strategy is particulate management followed by a water management program, both on the bulk side to the equation and for the on-engine / on platform vehicle, mainly the pre-filter between the fuel tank and between the engine itself. So with that being said, very short, very sweet. Any questions?